Hey there, everyone. So today is our last day of notes on motion, on kinematic motion. And specifically, today is our last day of notes on two-dimensional motion. So today we are going to focus a little bit more on projectile motion. And we're specifically going to look at projectiles and projectiles at an angle. So what I'm going to do is I'm going to go through some of the concepts with you first, and then I'm going to go through your last three in-class practice problems. So there are two different types of projectiles. First, we can have a projectile that's a horizontal projectile where something is being horizontally projected off of a cliff. And in this case, you're going to have motion acting in two dimensions, two ways. You're going to have motion acting in the x direction and then in the y direction. And something that you've seen from our previous videos is that the x motion and the y motion are independent of each other. The x motion is not being acted on by a force, so therefore it's not accelerated motion, but the y motion is acted on by an acceleration or by a force. And so therefore it is accelerating, it's accelerating downward. And so the distance downward gets greater as time goes on. In this case, the thing that we like about projectile motion launching at a horizontal is the fact that we don't have to take into consideration resolving our x direction vector and our y direction vector for our initial velocity. Our initial velocity in the x is equal to whatever our launch velocity is, and our initial velocity in the y in this case is equal to 0. Okay, so that is projectile motion not launched at an angle. But what if I go ahead and I add an angle here? So when I'm dealing with an angled launch, it becomes more complicated, okay? Because what ends up happening is now we have an angle, so we have direction in our x, and we have velocity in our x, and we have velocity in our y direction. Okay, so what ends up happening is we have to use our speed and the launch angle to find the horizontal and vertical velocity components. So our horizontal component, or our initial x velocity, is equal to v initial cosine theta. And it's because if you look at our trig function, cosine theta is equal to adjacent over hypotenuse. Well, our adjacent is equal to our v initial in the x direction, and our hypotenuse is equal to v initial. So v initial in the x direction is equivalent to v initial times cosine theta. Then we end up getting v initial y equals v initial sine theta. When you look at a projectile, the projectile motion is going to follow the path of a parabola, where you have our maximum height, or your maximum height. Your maximum height is all the way up here, and that's the point where the projectile changes direction. And the projectile, instead of moving upward, it's moving downward. At that point, it kind of stops moving, but only stops moving upward. It does not stop moving. It still has horizontal velocity, but it stops moving in the y direction, only momentarily though. That's the maximum height. Now the range is the distance that you travel. The range is going to be your change in x. So your range is change in x, and your maximum height is change in y. One thing that's really important for you to notice is that your acceleration due to gravity is always downward. It's always downward. It's not changing in its value. It's always acting the same, okay? So it's always going to be pointed downward 9.8 meters per second squared. Now, your velocity your velocity is tangent to the path of the entire trajectory. So notice we have our velocity vector here, our velocity vector there, our velocity vector there. So it's going to actually be a tangent line the entire path. Another thing to recognize is Vx is not changing, but Vy is, you start longer and then you get shorter and then go to 0 and then get longer and even longer. Okay, so the velocity can be resolved into your x components and your y components. And again, notice that the vertical velocity changes while the horizontal velocity remains the same. Now, your maximum speed is at the very beginning and at the very end, because something that's very important for you to notice, and we talked about this in free fall, is that your y velocity is the same in magnitude, but opposite in direction at the same exact horizontal height. Okay, so if that's true and your horizontal velocity isn't changing, this vector at the very beginning is equivalent in magnitude, not in direction. It's opposite direction. It's a negative direction, but it's equivalent in magnitude at the same exact height. Okay. Now, launch angle is symmetric with the landing angle for the projectile. Okay, so our angle here is going to be equivalent or equal to our angle there, except for one is our angle above the horizontal and one is our angle below the horizontal. Now, the time of flight for a projectile. The time of flight for a projectile, your projectile spends half of its time going up and half of its time coming down. Okay. So you basically could split that into two different times, but we're going to look at projectiles and times in two different ways. You can find half of the time going up and then the other half of the time going down, or you can find the total time of the entire projectile based on the fact that your v initial y is equal to your v initial or your v final y, but in an opposite direction. And also your change in y there is going to be equivalent to 0. So what I mean by that, in this graph, what we're doing is we're showing, so you would find half of the time, okay, and then multiply it by 2. So another thing that you could use is you could use that your v final y equals v initial y plus 2 Now, another idea that you can use here is you can use the fact that v final y is equal to v initial y plus acceleration times time. And you know v final y is really your negative of your v initial y. So you basically have negative v initial y minus v initial y, because their v final y is negative v initial y, and then equals negative 9.8 times time. And you could use that to find your total time as well. So there are actually two different ways that you can find your total time. So here's an example question. A soccer ball is kicked with a speed of 9.50 meters per second at an angle of 25 degrees above the horizontal. If the ball lands at the same level from which it was kicked, how long was it in the air? So you could solve this using the fact that you have your v initial is 9.5 meters per second, theta is 25 degrees, gravity is negative 9.8. So we're going to split our v initial y and our v initial x and try to find our time. Well, vy final equals v initial y plus gt. So your time is equal to vy minus v initial y divided by g. So in this case, you have 4.01 minus negative 4.01 divided by 9.8. And in this case, I actually used your upward direction as being positive, your upward direction as being negative and your downward direction as being positive. So you end up getting 0.82 seconds. Now, here's another question. We have a bullet is fired upward from ground level with an initial velocity of 200 meters per second at 42 degrees above the horizontal. What is the highest point above the ground level reached by the bullet? So you have your projectile 200 meters per second, and it's 42 degrees above the horizontal. So you need to resolve your vectors. You have your v initial x, and you have your v initial y. So if I split this into my horizontal and vertical, so I have my x and I have my y, then I know that my v initial x is equal to 200 cosine 42, which ends up giving me a value of 149 meters per second. Okay, and then my v initial y is equal to 200 sine 42, which ends up giving me a value of 134 meters per second. Okay, and so if I'm setting my positive as being my up, okay, and this is what's important. This is my positive y, and therefore this is my negative y. So in this case, my acceleration is equal to gravity, which is downward negative 9.8 meters per second squared. Okay. And what I want to do is I want to figure out how high that goes. Okay. Well, I have a v initial y, and at my highest point, what is my v final y at my maximum point? Okay. Your v final y at your maximum point is 0 meters per second. And that's because it stops moving upward and changes directions. So I have my v final y, I have my v initial y, and I have my acceleration. I have an equation that works there. I have v squared equals v initial squared plus 2a change in y, okay? And I can change my value. So this is v final in my y direction, v initial in my y direction. Well, this is equal to 0. This is equal to 134. So I have 0 equals 134 squared plus 2 times negative 9.8 times change in y. So when I bring that to the other side, I bring that negative 19.6 to the other side, I end up getting that my change in y is equal to 913 meters. Awesome. So many people are saying, I need to memorize the equations. I need to memorize the equations. My challenge to you is why? Look at what's on the equation sheet. See if you're given the equations that you need, and then understand how to use those equations and understand how to manipulate those equations to give you the equations that you need, okay? When you're working on these problems, though, I did see someone in the group discussion board that we did. I did see someone say that they found it very helpful to have the equations next to them while they are doing the problems. I could not agree with that statement more. So make sure that you have the equations next to you at all times. Okay, so a projectile is launched from a cliff at an angle of 35 degrees to the horizontal at a speed of 30 meters per second. What is the projectile's overall speed at the time that it has moved 200 meters in the horizontal direction? Okay. So you have a projectile that has been launched at 30 meters per second. And that projectile has been launched at a 35-degree angle. So I need to immediately split this into my x, or my horizontal, and my y, or my vertical, okay? And so in this case, I end up having that my v initial x is equal to my v final x, which is 30 cosine 35. Okay, so I end up getting that that is equivalent to 24.6 meters per second. And what I can figure from that is I can figure, since I know what my displacement is 200 meters. Therefore, I can figure out my time because I know Vx is equal to x divided by time. So I know that time is equal to x divided by Vx, which is going to be 200 divided by that 24.6 meters per second, meters, okay? And that's going to end up giving me a value of 8.13 seconds, okay? The thing that I want you to realize, most importantly, the one thing that ties X and Y together is they both have time in common. They both were looking at the time, the same exact time. We're looking at the position or the velocity or whatever in the same exact time. So let's look at our V initial Y. Okay, so because we know what our V final X is, okay, and our V initial Y is equal to 30 sine 35. And so that ends up giving us a value of 17.2 meters per second. And what we're really trying to do is we're trying to figure out what the overall speed is. Well, what's the overall speed? I know that my gravity is equal to, let's see, I've set my up as positive, and so therefore my down is negative. So I have negative 9.8 meters per second squared. So I use my equation V final Y equals V initial Y plus acceleration times time. So in this case, I have my V final Y is equal to 17.2 meters per second. Remember, that's positive, it's going up, plus negative 9.8 times a whopping 8.13 seconds. That's crazy. Okay, that's a long time. If you think about it, that gravity is acting. So you're going to get a negative value. You're going to get this negative 62.5 meters per second. Okay, and then now what you're doing is you're going to look at, so I have 24.6 going this way, and then I have 62.5 going down. What is my resultant vector? And that's where I figure out, I find my V resultant or my V total is equal to the square root of 24.6 squared plus negative 62.5 squared. And that ends up giving us a value of V final is equal to 67 meters per second. Okay. Now it says, what's the overall speed? Because you're being asked for speed and not velocity, you don't have to give direction. Okay. However, you could find the direction if you wanted to. You could find theta here because tan theta, I'm going to put this over here on the left, tan theta is equal to opposite 62.5 divided by adjacent, which is 24.6. And you could solve for theta that way. Okay, so you could figure it out if you needed to in this problem. Now, the next question is, if you have really gone through your textbook really well, then you have seen on page 60, I'm going to go ahead and write this up, Page 60, we have what's called the range equation. We want to, so if you look at this question, it says a slingshot fires a water balloon from ground level with an initial speed of V initial. So you have V initial at an angle of theta, okay, above the horizontal. Develop an expression for the range of the projectile in terms of the given variables. So we're basically trying to find the range, and the range is we want to figure out what is our change in x. Well, we know that change in x is V initial x times time, right? So we know that that's going to be V initial cosine theta times time. Now, I can't leave it like that because I want to solve it in terms of the variables that are given. And this is a very common AP physics type question. So when I look at this, I need to figure out how I'm going to find time. Well, if I used the equation change in y equals V initial yt plus 1/2 at squared. My change in y in this case is 0 because I'm going to my initial height, okay? So 0 is equal to V initial y, which is V initial sine theta, okay? Plus 1/2 times negative 9.8, okay? It's negative because I've set my positive as up t squared. And I actually forgot a t here. Okay, so I can go ahead and use the fact that that's a 0, and I can use the fact that I have 0 equals V initial sine theta, and I'm going to put that in parentheses, minus 1/2 times 9.8 times t, and then substitute out my t. So t could be equal to 0 in this case, okay? T could be equal to 0, or t could also be V, I'm going to move to the left-hand side if you can't see where I'm writing, V initial sine theta equals 1/2. I'm going to substitute my g for this, t. Okay, so then I end up getting that time equals 2 V initial sine theta divided by g. Okay, so now I'm going to take this t and I'm going to substitute that in there. So then I end up getting my change in x, or my range, is equal to 2 V initial squared sine theta cosine theta divided by g. And when I use trigonometric functions, I know that 2 sine theta cosine theta equals sine 2 theta. So if I take my 2 sine theta cosine theta, I end up getting that my change in x, or my range, is equal to V initial squared sine 2 theta divided by g. That took a long time, but it's worth understanding where it's derived from. So again, if you didn't follow something like that, take a look at page 60. The next question is determine the effect on projectiles' horizontal range if the initial speed is kept constant, but the angle of theta is decreased by a very small angle. Well, if you could just go ahead and plug and chug, and if you plug and chug, then what's going to end up happening is you're going to see that your range is going to go down. But something that I do want you to know before we end on these notes for today, I really want you to know that if two angles add up to 90 degrees, the range will be the same. So for example, if I have a soccer player kicks a soccer ball, okay, and say this soccer ball was kicked at a 60-degree angle, okay? If the same soccer ball is kicked at a 30-degree angle, because 60 and 30 add to 90, they're going to have the same range. 45 and 45 obviously will have the same range. If you had 20 and 70, it would be the same range, okay? And this is also discussed in your conceptual physics book. But I do want you to know that the range is actually going to be the same if two angles add up to 90 degrees. Hopefully that was helpful, you guys. And if it wasn't, please reach out. Remember, this week I am going to have Zoom meetings during class. So if you are a distance learner or you are in need of some extra help, please go ahead and check in with me, or make sure that you check in during tutorial on Tuesday afternoons. Thank you very much, you guys. Have a great day.